Hello dear students. In the previous video we have learned about concave mirror and their uses and some of their examples. So in this video we will learn about image formation by convex mirror. Okay. So what is a convex mirror? I have already explained you in the previous classes. So convex mirror is this type of mirror. This is the mirror where the image, the object is placed on this side of the mirror. That means this is the ray of light. Ray of light will fall on the convex surface of the mirror. Okay. Now from this side it is concave. From this side it is convex. Okay. I have already explained these things in the previous classes. So we consider two positions of the object for studying the image formed by a convex mirror. So in case of concave mirror, we were considering 5-6 positions, but in case of convex mirror, we will consider only two positions. Okay, two positions. First, what are the two positions? First, when the object is at infinity, and the second position is when the object is at a finite distance from the mirror. That means, suppose if I consider this as a convex mirror. Now this is the principal axis. Now this point is the pole. Okay. So first position is at infinity. Means object is will lie here somewhere. This is the object. This object will lie at a infinity distance from this mirror. Okay. Now second position is when the object is at a finite distance from the mirror. So this is the mirror. Second position is that Second position is that object is placed at a finite distance from here. So suppose this position. This is second position. This is first position. So from first position to pole the distance is infinite. To second position to pole the distance is finite. Okay, so these are the two positions. Okay. Reflection by a convex mirror. So you can see these are the two pictures. In the first picture, object is at infinity. Okay. Now see, this is the object. AB is the object here. MN is the convex mirror. The object is placed at infinity. Now in this second picture, this is picture number 1. This is picture number 2. In the second picture, you can see that object is placed at a finite distance from the mirror. Okay. Here. From AB is the object, P is the fourth. The distance is finite. Now in both the cases, if you see, the image formed is virtual one. Here, see at the focus in the first picture, from here, suppose if you consider three incident rays of light. So this is first ray, it comes and strikes on the mirror and it moves away in this direction. This is the second ray, it comes and it moves away in this direction. We have already studied in the previous classes about the law of reflection, and this is the third ray of light which is passing through the principal axis, and it will strike on the pole and it will move back in the same direction. Okay. Now here these two rays will meet at focus, and here virtual image will be formed, which is very diminished. Now in this case, the two rays of light will come and meet virtually at this point where the image is formed. Now the size of the image, you can see this is A dash, this is B dash. Okay, I have already explained you in the previous classes according to the rules how you can draw the diagrams. Here the first rule says that if the incident ray is parallel to the principal axis, that is this ray is parallel to the principal axis, then it will, in case of concave mirror, it will converge. In case of convex mirror, it will diverge. Okay, and if you pull this one in the backward direction, it will pass through the focus. Now here this is the second ray. If you extend this ray, then if it is passing through the point C, that is center of curvature, then it will move back through the same path it came. Now this two virtual line, that is this line and this line, will meet at this point. So at this point, image will be formed. Now you can see here, as the rays are not actually meeting, this is virtual image. Size of the image this much compared to AB is small, so diminished. Okay, so nature of the image is virtual and diminished and erect. Okay, erect means it is vertically upward, it is also vertically upward. Okay, now uses of convex mirror. What are the uses of convex mirror? Rear view mirror, mirrors in vehicle, sides of the vehicle. You might have seen the mirror which are used in vehicle. While you are driving your bike or driving your scooty, the mirrors which are used with your handle, through which you can see the backside image, those are convex mirror. Okay. So our next point is sign convention for reflection. This is very, very important. Here we follow the Cartesian sign code conversion or Cartesian sign coordinate. Cartesian sign coordinate is in our mathematics in graph paper the sign that we use. Suppose this is the center. So this side of x-axis is positive. This side of x-axis is negative. This is y-axis. This side is considered as positive. This is considered as negative. This is center or origin. So this same sign will be used here. So here the origin will be considered as pole of the mirror. Okay, so suppose in case of concave mirror, this is the pole. So this point will be considered as origin. In case of convex mirror, this is the pole. So this point will be considered as origin. Okay. And the pole of the mirror is taken as origin, as I have just explained you. The principal axis of the mirror is taken as x-axis of the coordinate system. So this is the principal axis of the mirror. This is the principal axis of the convex mirror. So this axis will be considered as x-axis, as this one. Okay. The conventions are as follows. First one, the object is always placed to the left of the mirror. This is very, very important point. You should remember this one. So suppose this is the mirror. In case of concave mirror, the object, so this is the principal axis, the object will always consider in this side, not this side. Okay, in case of convex mirror also, the object is placed on the left hand side of the mirror, not the right hand side of the mirror. Second point, all distances parallel to the principal axis are measured from the pole of the mirror. So whatever the distance you are going to measure, the distance means the distance of the object or distance of the image, it will always be measured from the pole of the principal axis. Okay, that means from this point, this point. Okay. Third point, all the distances measured to the right of the origin along plus axis are taken as positive, while those measured to the left of the origin along negative x-axis are taken as negative. Obviously, this is as because we are following the Cartesian coordinate system. This is the origin which we will consider as pole. This is x-axis. The left side of the x-axis or left side of the pole will be considered as negative. The right side of the pole or right side of the origin will be considered as positive. Okay. Fourth point, distances measured perpendicular to the above principal axis along y-axis are taken as positive. Distances measured perpendicular to the to and below the principal axis along y-axis are taken as positive. Negative. That means this side it is taken as positive, and this side it will be taken as negative. Okay. Next point is mirror formula and magnification. This is the most important point in this chapter. Problems will be asked based on this formula only. So here object distance is considered as u. Okay, it should be small u, not capital U. U. Image distance will be considered as v, that is small v. Focal length is considered as small f. So what is object distance? If I consider this mirror, suppose object is placed here. Object distance is measured from the pole to the object. So this distance is measured as u, object distance. Now you can see that this is the pole which we are taking as origin. So as object is lying on the left hand side of the pole, we will consider its value as negative. Now suppose from here pole to the object the distance is 5 centimeter. Suppose. So here u will be equal to minus 5 centimeter. Okay, why we have taken minus 5? Because in the sign convention we saw that the if the object is lying on the left hand side, then we'll take it as negative as per the Cartesian coordinate system. Now, image distance, suppose image will form here, suppose here somewhere image will form. So this is the image distance from here to here. It will be considered as V. Now suppose the distance is 7 centimeter, suppose. So here V will be equal to plus 7 centimeter. As why we are taking this one plus? Because it is lying on the right hand side of the pole. Okay, so here this side is negative, this side is positive. Now next one is focal length. Okay, so focus we have already discussed what is focus and what is focal length. Okay, focal length is fixed for a particular mirror. Now there is a relationship between these three quantities given by the mirror formula, which so there is a relation between object distance, that is u, image distance, that is v, and focal length f. So this is the relation. You should remember this relation. It is very very important. 1 by v plus 1 by u equal to 1 by f. Okay. Now, some important points. This formula is valid in all situations for all spherical mirror, for all positions of the object. So, whether it is concave mirror, whether it is convex mirror, whatever the position of the object, it does not matter. For any position of the object, you can apply this formula. Okay, in case of convex as well as concave mirror according to their respective value. Sometimes it may be positive, sometimes it may be negative, it doesn't matter. But for any position, you can apply the same formula. Okay, with respect to Cartesian coordinate system. We will cover some of the examples so you will have a better idea. So this is one of the picture from your NCERT book. See here it has taken one example of concave mirror. You can also take example of convex mirror. So this is the if the object is from the principal axis, if the object is lying on the vertically upward side, then it is taken as positive. Downward side, negative. From here, left side it is positive. Right side, sorry, from here it is left side it is negative. Direction, this is the direction of incident ray. Now this side, distance toward the right, it is taken as positive. Okay. Now object on the left. So object will always kept on the left. You should keep this one in mind. Okay. Our next point is magnification. What is magnification? Magnification is nothing but the comparison of size of the object and size of the image. Okay. The ratio of the height of image to the height of object. Height of image, if I consider I as image, height of image divided by height of object, that is called magnification. Okay, I by o, that is height of I, height of image divided by height of object, that is magnification. It is usually represented by the letter m, small m. If h is the height of the object and h dash is the height of the image, then magnification m produces by a spherical mirror is given by see m is the magnification. Magnification is equal to height of image h dash by height of object h. Here I have taken image as I and object as O. So m equal to h dash by h or I divided by O. Okay. Here the magnification m is also related to the object distance u and the image distance v. Now in the previous slide we saw that magnification is equal to height of the image divided by height of the object. So it can be represented in another way. That is, magnification m is also related to the object distance and image distance. That is, image distance divided by object distance. Image distance, that is divided by object distance. So let me clarify this one. So we can draw an image. Suppose this is principal. Suppose this is principal axis. Here we can draw an image and we can clarify this thing. So we consider a concave mirror. Suppose this is principal axis. Okay, now this is focus. Now this is center of curvature. This point is 4. Now if the object is here, if we consider, then this ray will pass through the focus. Now here this is the point where image is created. Okay, so here the height of the object is h, height of the image is h dash. This is the distance of the object from the principal axis, that is u. This is the distance of the image from the principal axis, that is v. So here magnification m equal to s dash, that means this height of the object divided by height of the magnification is equal to height of the image, that is this is the height of the image divided by height of the object. This is height of the object h, or it can be considered as minus, that is negative of v, that is image distance. This is image distance, this one, this here from P to C, this is image distance divided by object distance. This is the object distance. Okay, so note some important point. A negative sign in the value of the magnification indicate that the image is real. So here you can see that we are just taking the ratio. Okay, we are taking the ratio. This is lying, both u and v both are lying on the left hand side, so it is minus u, it is minus v, that is it should be minus v divided by minus u, which results into v by u. So why there is a negative sign? The negative sign means the image is real. This is real image. So in case of, if it is virtual image, it will be v by u. If it is real image, it will be minus v by u. Positive sign in the value of the magnification indicator, the image is virtual. So this point is very important. It might be asked as a short question that if magnification is positive or negative, which kind of image is it? Is it real or virtual? Okay. So here are some of the examples. We will solve these examples in the next video. So today I end this video here. Thank you and have a nice day. But if you still have any doubt, you can comment me. Okay.